Welcome back, students. Now we are going to discuss about the basic natures of amines part 2. Let's start with the first amine compound, that is ammonia. Now to this ammonia we made a primary amine, next we made a secondary amine, and third one we made a tertiary amine. Now students, spot the difference out of this. The very first basic difference is that primary amine consists of one R group, secondary consists of 2 R groups, and tertiary consists of 3 R groups. Now, a very basic point that all the R groups are electron donating groups. So therefore what we would get in tertiary amine, there would be a plus I inductive effect, but it would be 3 plus I inductive effects. Whereas in secondary amine, it would be only 2 plus I inductive effect. Hydrogen would have no crucial value of inductive effect. And in primary amine, it would be only 1 inductive effect, whereas in ammonia, no inductive effect would be present. Now, because of this, what we can say is that the basicity order of aliphatic amines should increase as the alkynes or as the ammonia gets substituted with more alkyl groups. Further, therefore we can say a tertiary amine is greater basic than secondary, and secondary is more basic than primary. But remember student, this is true only in the gaseous state or only in the gaseous phase. It is not true elsewhere. So let's move further and now discuss what if we have an aqueous solution. Now, in aqueous solution, the very basic points, the first thing we need to consider is that there is solvation of ammonium ion. The next thing we need to consider is there is steric hindrance due to alkyl groups. And the third thing which we cannot forget is hydrogen bonding with water molecules. So, whenever you are mixing ammonia or any amine with water or aqueous solution, you need to consider all those 3 points. Now, all these 3 points should be considered, right? But the problem here is, according to all these 3 effects, the order of basicity for aliphatic amines should be normally considered as primary greater than secondary greater than tertiary, because primary would be not forming more steric hindrance, or rather it would form more hydrogen bonding with water because it has more capacity to aggregate. Secondary a little less, tertiary very less. Let's move further now. This was true only in the aqueous phase. Extending this, what we need to know that basically the basicity of amines is hugely dependent upon their alkyl groups. So students, just remember that this is true or this is a generalized statement, but now whenever an alkyl group would go on changing, this generalized statement would go on changing. So now what we would say is, let's take a case 1 wherein R should be equal to CH3 group, that is all the R's are CH3. Now what will happen? Then the basicity order is secondary greater than primary greater than tertiary, and that would be greater than ammonia. But if R is not equal to CH3, then what would happen? Then you need to know that this is not followed. The order followed is secondary greater than tertiary greater than primary greater than ammonia. So a very, very important point you need to remember over here, students. Let's move further. We discussed about aliphatic amines. Now let's also talk about aryl amines. Now it is already said that aryl amines are less basic than aliphatic amines, and I know that yes, you are pretty aware with the reason. The reason for this is resonance. Now let's see what happens. NH2 would donate its lone pair towards the benzene ring, and because of this, the conjugation the less electrons or less number of electrons are available for donation. And if there is no donation of electron, this compound would not be acting as in Lewis base, because any compound which accepts electron would act as in Lewis acid, and any compound which donates electron as a Lewis base. So if this ammonia molecule could not donate electrons, it would be a Lewis base, but it would be a weak Lewis base. Now what happens further is, hence anilines or any other aryl amines are less basic than ammonia also. And because of this, what we would say, the order of basicity now is aliphatic greater than ammonia and ammonia greater than aromatic amines. So this was the order which you need to remember. Fine? Let's move further. Now, in case of substituted anilines, let's talk about something. Here you have an NH2 group, which is an electron donating group. Now, instead of this electron donating group, suppose if I add some other electron donating group as well, that is CH3, NH2 or OH, then what would happen? Then the basic strength would go on increasing, because benzene would receive more electrons. No electrons of ammonia would be taken for conjugation. Let's see further. If NH2 or aniline was added with an electron withdrawing group, like groups such as NO2, CN or COOH, what they would do? They would pull out the electrons of benzene. So benzene would definitely pull out the electrons from nitrogen. And because of this, the basic strength would go on decreasing. So this was all for this module, students. Meet you in the next module. Till then, thank you.